my speech today will be about industrial and all these things, how we use artificial intelligence in business. And, when I was preparing for this talk, I was thinking that probably it's such a topic because complicated. It seemed to me quite complicated to explain why are we doing AutoML, in 2025. How would I explain that at the conference where everyone is talking about RAG systems, LLMs, agents, and all these things? Why am I here to talk about encoder-based solutions? Like, what for? But the reason about we're doing that is extremely business reasons. And that's why, because of this worries, I want to thank you, Sergey, for his previous speech. It was absolutely brilliant. Thank you so much. You've explained very deeply why it is still important in 2025 to use other solutions except LLMs. You've talked a lot about pros and cons of LLMs, RAG systems, agents, and so on. And everyone here, and everyone in our industry, we understand that agents is the future, and we need to build them. And business wants to earn money, and as has already been said, AGI, in one kind of definition, is something that can earn profit of some huge amount of money, and business wants to earn money. So that's why we want to create products that help building agents. But for building agents, we still need business profit. And LLMs have a lot of cons that also has already been spoken. Yeah, the latency, computational resources, it's very difficult to scale, especially in big businesses where data safety is quite important, where it's can cause some law problems, and so on and so forth. That's why in these cases, in some tasks that are needed to be done to create agents, for example, task of routing between different agents, routing between the intentions of our users inside the agents, and some other tasks that need to be done to perform chatbots in agents. We still want to use encoder-based models because they provide us interpretability, which is important in some spheres like banking. It is prohibited by law. Do you know that it is prohibited by law to use non-determined algorithms in banking scoring, for example? So we just cannot use LLMs there for some decisions, right? Also, hallucinations and error handlings. If we build agents or chatbots for business purposes, right? Our users can come to us with tasks connected with the money transferring or something like this, and the cost of the error there is quite high for the business, and that's why we want to be sure, that we can control everything that is happening there. So that is why we have created AutoML. We haven't created any good name for that. If you have any idea, please share. We still need it because it's just a part of the huge product, like a platform that helps creating agents. So we have created a whole part of this product that helps us to build so-called previous era discriminative AI, but it still works and works pretty well in business and in industry. So the thing I'm talking about today, it's not more about data science or research things, but it's more about software engineers work, and actually very accurate and precise experiments, and dedicating the correct way of creating pipelines of well-known, quite long existing approaches to solve the problems. So here are the steps of working with data that we implemented in our AutoML kit, I would say kit, right? In real life, it exists as, I think, contains of two parts, AutoML Python library, which is going to be open sourced couple of months. And whole product stuff around that. The dev interface about it and UX interface for the users that can create models for classification and sequence labeling without any help of ML engineers, with just pressing 2 buttons. The one is to upload the data, and the other is to train the model. And also the inference is handled by our program, our system. So what have we done? First of all, we have worked a lot on the module of data quality checking, because the main idea about all the AI we know is garbage in, garbage out. So we have to work on data. If we remove ML engineer from work on models, we have to be sure that we've done our best to clean the data, to do everything for the good quality. So we have implemented 5 algorithms that help us to find mislabeled data, some broken data with probably some mistakes, misspelling, and so on and so forth. I will not tell you about all the 5 algorithms. We just don't have enough time for that. But I will tell you about the 2 most interesting, I think, from the DS point of view. The first one is dataset cartography. Probably you have heard about it. The idea is quite simple. So we have 3 metrics: confidence of the model, variability of data, right, and correctness. So using these 3 metrics, we can build a map, yeah, and we can sort of cluster our data. Yeah, every point here is one sample of data set. So we can cluster it into 3 areas, into 3 classes. Easy to learn for the model. In the upper left corner, these are the examples that are not variable. So they are almost the same, they look the same, and they are very easy for model to learn. So actually they are useless for the model because it's quite the same samples, then no generalization can be done there on this kind of data. And in the down corner on the left, you can see similar examples, but hard to learn for the model. So the idea is that these examples of data, they're still not very various, so they look the same, but for model, it's quite easy to learn the wrong label for these samples. And the authors of this approach, in their article, they say that usually, they've checked it on several data sets, usually these examples, hard to learn, not various and easy mislabeled, they are usually mislabeled data. So yeah, it's quite easy to find this mislabeled data using this algorithm, but the problem is that this approach is only works with visualization, so you have to build the graphics and look at this. So it requires someone who can read graphics, and it doesn't sound like AutoML. So we have to make some more researches there to find the proper thresholds on these several metrics, yeah, and to make it adjustable according to the data set. And it was implemented in the library. And also for the classification, we used reusable information. This is quite an interesting thing. Actually, reusable information just shows how much information from sample, from data, a model can use to learn. Yeah, so actually just shows how much important useful information consists one's data set. And there is also point-wise reusable information, so it can be counted for one exact sample. And we also conducted some experiments combining these 2 methods, and it shows the correlation between the reusable information score and these 3 groups I have talked to you before, right? So if we say about the information, when it's negative, it means that there is no useful information. Like it's even bad information for the model. So of course, it's correlated with the hard to learn examples, but at the same time, the problem with reusable information approach is that negative score of reusable score, yeah, it can mean not only that the data is mislabeled, so bad data, but it also can mean that this data can be from easy to learn part, because it's also useless for the model. So we have to combine these two methods and accurately find the threshold for all the scores to clean the data properly without missing too much data, and finding mislabeled data if it exists in the data set. Here is the results of our benchmarking. We used two methods and checked its ability to find the mislabeled data in datasets. So we spoiled 15% of data manually in our dataset, and then we made our methods to find the spoiled data. So the results of this is here. And for users of our library, it's not needed to know all this inner information. You can use it just by calling one method. That's it. And for users with UI, they don't even know that any kind of data quality checking exists. Everything happens just inside it. And if any bad data is occurred, it's just cleaned and is used. And clean data is used to train the model. We also performed some. We also performed some experiments on data preprocessing. We added some augmentation algorithms. I think first of all, it's better to start with the model selection, and then I will come back to augmentation. It will be easier to follow. We have implemented 3 ways of creating a classification model and 2 ways of creating a sequence labeling model. Usually we use it for named entity recognition tasks, so that's where we focused. 2 methods of classifications are a few shot, and we also conducted some experiments to find out the thresholds that are the most suitable to use these or that methods. And we found out that classic fine-tuning works good, and it can be used when you have at least 80 sample per class. And same we did for near task. And we also benchmarked all of our models, all of our not our approaches to train the models on different domains, medicine, finance, and e-commerce. Here you can see the results. Reference value is a sort of value on these data sets. So yeah, we have a little bit smaller results, a little bit smaller quality, but still, this is AutoML. No ML engineers have touched the model to perform such quality. So I believe that in production, that this is quite a great result. Yeah, and especially if we know how much ML engineers earn to create these models. And now you can do it just by using one button. And also, at MTS AI, of course, we create our own chatbots and agents for the big MTS, and we have a separate team that create custom models for them. And we also have benchmarked on our own data sets and compared it with our custom models. And here you can see that on some tests, we even outperform custom-made models. But in several, mean deviation of AutoML model on our data is just 0.025 for weighted F1. Yeah, and one more thing that we have made to obtain such results was augmentation. There were a lot of experiments actually to find out the threshold of augmented data that we need to use. So first of all, the experiment was that we have a few short approach and fine-tuning approach, and we need to find the threshold which is appropriate to use if we have some low resource classes, so some classes have enough samples to be used with fine-tuning methods, and some of them are not. And we needed to find this threshold of number of classes, low resource classes, where it's convenient to use few short and where it is convenient to use fine-tuning. This threshold was 30%. If 30% of your data is low resource, it's better to augment it. If it's more than 30%, it's better to use a few shot approach. And also we compared several ways of augmentation, also with the LLM, and found out that Augmentex that doesn't use LLM performs same or better than LLM, and the latency is better, the resources are lower, and so on and so forth. Yeah, and here is also the benchmarks on several data sets with different augmentation proportion size. Yes. And also just a couple of words about development part. All the previous talk was about AutoML library, the package, Python package, and the ML part, but the product part is also quite big. It contains everything about inference of the model, automatic deployment of the models, and everything. So just 3 buttons. Upload data, train model, and deploy your model. And you can use your model in any agent that you create. And I want to thank you, my wonderful team that have been working with me on this product. These people are wonderful. Yes. Thank you very much. I hope it was at least interesting from the business point of view for you. Yeah. And descriptive AI is not that yet.
Thank you, Daria. Do we have maybe questions from the audience? Yes, please.
Yes. Can you return to the slide with dataset cartography? So we can see probability in confidence and variability. How do you estimate this probability?
The probability of correctness.
In formulas, we have probabilities.
Oh, okay, I see. In confidence, you mean?
Yes, in confidence and variability too.
The confidence of the model is just uncertainty estimation of the model. So yeah, log probability of the model, and variability. Yeah, we count just the main deviation between the embeddings.
Okay, so is it exactly?
It's exactly confidence of the model, yes, and exactly variability. That's simple, yeah.
Yeah, I got you. Thank you.
Simple, but works very good.
Thank you. Any other questions?
Thank you for the interesting presentation. My question is, where do you use AutoML, and what would be like a case is that that you take? I don't know, say data scientist. Now you go and thank you very much. Now just one person will be doing that, or like what's really if we talk about business, what would be like the case, or you give it to some department which doesn't have DS capability, and but still they need some training, right, to kind of understand, because once you start saying like recall and precision, they would be like, wait, we need some sort of we need some sort of training or something, because we understand like money and we want this, and I don't know, how do we go with this?
Yeah, sure. Thank you for your question. Actually, we already are using this inside MTS AI, and I also use it in our bigger product. We are building a platform for creating chatbots and agents, and the UX of the platform is no-code platform. Yeah, so they build it with interface similar to Langflow, if you know, from these blocks with no coding at all. And actually all ML part is hidden. So they just make these business scenarios using these blocks. They insert some examples. So for them, it's just intents, like business intents of their users. They can call it something like, I don't know, check the balance, for example, yeah? And then they insert some examples of their user's speech inside this box. For them, it looks like this, just several of them. That's why we have implemented a lot of few-shot solutions for them. And that's it. For people who create agents, it looks like this. They have boxes connected with arrows. This is the scenario for them. And everything about training the models just happens inside. We collect the data. So we have a dev backend that collects the data from these boxes, convert it into data set, and then call all needed methods from the AutoML package. And then we automatically deploy the model, and this model is connected to the bot or agent that the user of the platform has created. Yeah, that's the way how it works. So we have, I forgot the word. Спрятать, do you remember? Yeah, we have hidden everything inside. Yeah, so business cases are mostly for creating the chatbots, and there's the classification task between routing between the intents of the users and some additional tasks that are helpful to understand the intents, like slot filling, all this stuff.
Yeah, thank you.